Hello everyone, we the students of Vishwakarma Institute of Technology are here to explain about direct memory access, which we will be referring as DMA. We belong to Division Q and Group 6. First, let's understand what are types of input-output techniques. So there are three types: programmed input-output, interrupt-driven input-output and direct memory access, which we will be discussing in this video.
DMA is a technology that allows peripheral devices to directly access the computer's main memory. The peripheral devices can transfer data to or from memory without involving the CPU, freeing it up to perform other tasks. A dedicated hardware module called the DMA controller is responsible for managing the transfer of data between memory and peripheral devices. This can significantly increase data transfer speed compared to using the CPU to data transfer, as the CPU is freed up to perform other tasks while the DMA controller handles the data transfer. DMA is commonly used in computer systems for tasks such as data transfer between memory and peripherals and audio and video playback.
Now let's move on to the working of DMA. At first, the peripheral device transfers data directly to or from the memory. Then the CPU sets up the transfer, that is, the source or the destination address and the data size. After that, the DMA controller manages the transfer and communicates with the peripheral device and memory. Lastly, the DMA controller performs transfer while the CPU performs other tasks. Thank you.
Now let's look at the types of DMA. First one, we have simple DMA. This is the most basic type that transfers only one byte at a time. Out of all DMA, it is the slowest one but the simplest one to be implemented. Next up, we have cycle steal DMA. It steals a memory cycle from the CPU to perform a DMA transfer. Well, this is faster and simple than DMA but still slower than the other types. The final one, we have a block DMA. This blocks data into a single transfer, offloads the transfer from the CPU, and this allows it to perform the other tasks.
Now talking about the advantages of DMA. First, DMA increases the data transfer rates. DMA allows data to be transferred directly between the memory and the peripheral devices. It bypasses the CPU and reduces the workload on it. Second, DMA improves the system performance. Since the DMA transfers data without involving the CPU so that the CPU can perform the other tasks, and it leads to improve the system performance of the computer. Now third, DMA reduces the CPU overhead. DMA eliminates the need for the CPU to constantly monitor and manage data transfers, and it reduces the CPU overhead.
Now let's talk about the applications of DMA. First, hard disk drives (HDD). DMA is used for transferring data between the HDD and memory, which allows for fast and efficient data transfer and reduces CPU overhead. Second, sound cards. DMA is used for transferring audio data from memory to the sound card for playback, freeing up the CPU to perform other tasks. Third, network adapters. DMA is used for transferring data between the network adapter and memory, which allows for fast and efficient data transfer and reduces CPU overhead. Fourth, graphics card. DMA is used for transferring graphical data from memory to the graphics card for display, freeing up the CPU to perform other tasks. Thank you so much. This was our time.